A viewer noted that there is a new update to the Siglent firmware that adds CAN and LIN decoding, and since I'm working on a re-edit of the entire decode, trigger and decode section, I thought it would be a good idea to download that. So that's what I'm in the process of doing, is downloading. Well, it now says updating 100%. And so I think now all I have to do is restart the scope and I should have those new features. So now I'm reloading. Scope appears to have come back up. Okay, well now I'm going to go check and see what we have in the way of decodes and see if there's a CAN and LIN, and I understand there's also a few other updates to like the video trigger, which I didn't review, and some other things. So I'll let you know in a second what I find out. Okay, the scope has updated. I'm now going to press the protocol, and sure enough, it says that in addition to the types that I already have, there's also a CAN and a LIN decoder, which it did not show before. So something has changed, and I think at this point I'm not going to try to use the CAN and LIN decodes right now. I'm going to finish editing this, but I may prepare a supplementary video at some point in the future with CAN and LIN decoding. Now, CAN and LIN are not used that much. They're primarily used in industrial and automotive applications, but nonetheless, they are useful decodes, and they're still used quite broadly in the automotive industry and in certain parts of the industrial machinery business. And let's get on with re-editing this, the trigger and decode section of the comparison between the Siglent and the Rigol. Moving on to trigger functions, I've prepared a table here that shows the various trigger functions that are available with the Rigol DS1000Z and the Siglent SDS1000X. As you see, the first group from edge, pulse, slope, video, runt, window, and timeout are available in both scopes. Though with the Rigol you have to pay an option fee for the runt, window, and timeout trigger. If you pay that fee, you also get these functions, which the Siglent does not have. That is delay, duration, setup, and hold. You also get an nth edge trigger. There also are triggers that work on various buses, RS-232, SPI, I2C or IIC, depending on how you pronounce it. The reason that I put the stars here by these three is one of the things that you'll find is sometimes something is listed as being available in one scope but not in another. What I hope to show you is that these three functions, although they are not explicitly present in the Siglent, you can do with their pattern trigger. Their pattern trigger allows you to do an AND, an OR, a NAND, or a NOR on the two signals. The Rigol only allows you to do an AND. I'm going to try to show you how you can do things like, for example, setup and hold using a pattern trigger to do the same thing as a setup and hold trigger. In triggering the scope, one of the things that you have to work with is the various triggering controls and menus. On the Siglent, you select those over here with the trigger section, which includes a setup key. When you turn on the setup key, you get a series of menus that allow you to select the type and a bunch of others which we'll go through. On the Siglent, once you've selected the trigger menu, you can then pick the type of trigger. You do that by pressing the type button, and then you scroll through the various trigger types: edge, slope, pulse, video, window, and you may notice over here on the right it shows what is actually going to happen. So for example, as you go through these, of course there is the edge trigger, and one of the differences here is that with the edge you get either rising, falling, or both. That is, a rising and a falling. With an edge trigger, the scope is going to trigger on a transition, that is an edge in the time domain. You need to select the source, channel 1 or channel 2. Obviously, if you select channel 2 and you're only using channel 1, you won't get any synchronization. There also is an external trigger which is present on the front panel in the Siglent. I think the external trigger on the Rigol is in the back. So let's go to edge trigger. In this case, you have a rising edge. You can also select a falling edge. Now let's look at the slope trigger. What the slope is doing is it's allowing you to set a time window and look at the slew rate of the signal through that time window. So if you think of it this way, it's saying you can set a lower level and an upper level, and to trigger, the signal has to pass between the lower level and the upper level in some particular time frame. So once again, you have to set the source, you have to set the slope, then a limit range. In this case, my limit range is within the time window that I have set. I'll talk about that in a second. You can also have it be outside the time window. Obviously, for this signal, outside the time window isn't going to synchronize because there are no pulses outside the time window. Here is the less than the time window, and notice that in this case there no longer is a real window, it's just a value, in this case 10 nanoseconds. You can have a greater than, and in this case I have it set to 2 nanoseconds. When you go to one of these greater than, less than, you may notice that the lower value is the 2 nanoseconds, the greater value is the 10 nanoseconds. The next page allows you to set the lower and upper values. It also allows you to change the coupling now and turn the noise reject on and off. And one of the things that you might be interested in is, why would you want to look at a slope rather than just an edge? The reason is some circuits are sensitive to the slope. For example, some logic gates, if the slope is a little bit too slow, they will actually oscillate on the output during the time that the signal is transitioning from what is essentially the 0 level to the 1 level. One of the reasons that Schmitt triggers are often used is they are not as sensitive. They basically latch when it goes above a certain level and switch quickly. But if you take an ordinary logic gate and you slow down its input, you'll find that particularly the high-speed gates will start to oscillate somewhere in this middle range. So you might want to look at the slope to determine, is there a signal in my system that is moving too slowly to be used in a logic gate, and if so, I might need to put it through a Schmitt trigger or some other kind of circuit that has a little more hysteresis, or in other words, does not oscillate in the center. I've now selected the pulse type trigger, positive going pulse. I've set the limit range to less than 5 microseconds. This happens to be a 10 microsecond period, or in other words, the positive pulse is 5 microseconds long. So if I reduce the limit range below 5 microseconds, you notice that the scope stops triggering. The purpose of the pulse trigger is to allow you to look for pulses to see if they are within your design spec. If the pulse is smaller than that, you can use the limit range. You also can use a greater than symbol, and in this case my greater than amount is 2 nanoseconds. I can also use a within range. Here it's 2 nanoseconds to 2 microseconds. So let's reset that. By the way, you switch between them by doing this. So let's reset that to 5 microseconds. Now we have this set to 2 microseconds, or 2 nanoseconds, and this set to 5.62 microseconds. Well, a 5 microsecond pulse fits within that window. Obviously, one of the reasons you would use this is, for example, if this were the clock signal in a synchronous logic design, there are certain specifications that the clock signal has to meet. And if the clock signal has some variation to it, either due to the signal itself or due to noise getting into the signal or something else that is upsetting the clock generator or the clock distribution network, you need to know if there are pulses that don't meet the clock specification. And that's one of the uses for the pulse type. We've now switched to the interval trigger. Same source, channel 1. In this case, rising, I think just for variety, I'm going to switch to a falling edge. I'm going to set the limit range to be greater than some amount. In this case, it's greater than 11 microseconds. Now we will reduce that limit. And you notice it's triggering. Let's now raise that limit above 10 microseconds. And you notice that the scope stops triggering. The interval is measuring essentially the time from a rising to a rising or from a falling to a falling. Basically the period of the signal. And it says it has to be within a certain range. In this case, we're saying that it has to be greater than 21 microseconds. Well, this is a 10 microsecond period. So as I reduce this below 10, it's now at 989 nanoseconds, or 0.989 microseconds. It's greater than that figure, and in fact it will continue to work all the way up to 10 microseconds. There's 10.6, and as soon as I go below 10, it triggers because I'm looking for pulses that are greater than this figure, and this is a 10 microsecond period, so it will now trigger on that. That is the interval trigger. This is useful in situations where, for example, you have a signal, a clock signal, for example, and you need to determine if there are any clock signals or any data signals for that matter that fall outside a particular range. Notice that you can use the greater than, you can use the within a range. Once again, you can set two different values. Outside the range, and in this case it's 2 nanoseconds to 2 nanoseconds. So obviously a 10 microsecond interval is outside the range of 2 to 2. Or you can go to less than, and in this case it says less than 10.2 microseconds. Once again, if I reduce that below 10, it loses trigger. Once it's above 10, it triggers again. I've been trying to figure out the Windows trigger of these two oscilloscopes, and I first have to admit that I've not used Windows trigger before, and I noticed something that's different between the two scopes. The Rigol has the ability to decide whether to look at the for the window type to either trigger on the rising, that is entering the window, or the falling, that is leaving the window, or both. But apparently Siglent does not have that ability. apparently you're forced to use the both, and it says that in the manual as well. So here's the problem though. When you set this up, you'll notice on the right over here are the two cursors that define the window, and as I go up, you'll see that there's a little jitter when it moves from one group to another, but it fairly consistently just moves right on up. That is, it doesn't matter where on the waveform you position the window. And remember, this is the signal that Rigol suggests that Windows is useful for. Anyway, that works fine. On the Siglent, however, when I do the same thing, you'll notice that right now the bottom of the window is outside the waveform and the top of the window is inside it. But watch what happens now as we move up. We get to a point where, now there you can say, well, maybe it's because the triggers or the window is going right through the level. But you move further up here where it's very clearly not on the exact level, and it still won't really synchronize. It sort of double triggers. Now, I'm puzzled what's really going on here. I don't know if it's because you can't select the rising or the falling, or whether because when I go to window type over here and select the both type, the Rigol still appears to work stably, although there are situations where it will double trigger. But as you move into an area, it seems to trigger more reliably on the window. So I don't know if there's something that I'm doing wrong or just don't understand the Windows trigger. But at any rate, I'm going to leave this at this point. I was mistaken about the Siglent having CAN and LIN bus triggering and decode. If you actually go to the menus for decode, there are no CAN or LIN modes. So those are some of the changes that I've had to make to this comparison chart. And so now let's move on and look at a few of the Rigol trigger functions, some of which are identical to the Siglent and some of which are superior to the Siglent because it doesn't have an nth edge, but some that are inferior, like Timeout, where Siglent's dropout appears to be Timeout plus more. I've set up an arbitrary function on the Rigol generator to generate a pulse, a normal pulse, and then a Runt pulse. This is a rather simple one. Then I've applied it to both the Rigol and the Siglent. And I've put both in the Runt trigger mode. Now, I'm having a little bit of trouble with the Rigol because if you'll notice here, the way the Runt trigger works, and maybe I should just talk about that first. If you have a normal pulse, like a clock or a data signal or whatever, and you know what its normal height should be, anything that's very much above that height or anything very much below are considered abnormal, and you look for those. These are pretty easy to find without anything special because you can just set your trigger level above the normal, and if there are any pulses up there, it'll sense them. The harder one to find is this one, and the reason is if you set your trigger level here, anywhere in the middle of this pulse, it'll also detect or trigger on this pulse and this pulse. So modern scopes often have a Runt trigger where you can set an upper level and a lower level, and it will trigger on that. This may look a little bit like the window function that you saw earlier. And so also sometimes runt triggers are considered to be triggers that are narrower than the normal, or in rare cases perhaps even wider than the normal. I've already talked about pulse triggering, which will usually find those for you. Also, you might want to use the interval trigger, which is available on the Siglent but not on the Rigol. So this is the display, and over here you'll see a window set where you can adjust the bottom window or the top window. So right now I'm doing the bottom cursor, if you will, and you see if you go up here it loses trigger, which it should, because there are no pulses that are taller than that. And as you come down into the runt region, it senses the runt and triggers on it right there in the center. The problem that I'm finding with the Rigol, though, is if you take this trigger down very far, it loses it again. Come back to triggered. There's where it is. And then as you go down, it loses the trigger. The reason that's a problem is you don't know ahead of time how big this runt is going to be. And so what you'd like to do is set this trigger way down here and move this one down just a little below that, so that anything in this whole area here will get caught. For some reason, the Rigol doesn't seem to want to do that. On the Siglent, let me move this cable out of the way here. The windows are over here, and you can get to those by using this lower upper. So here you have, you can set to do the lower, and what I'm going to do is switch to lower, and then over here you see when the lower goes below that level, it stops triggering, but as soon as it comes above this level here, it triggers. And so you can set this one. Now let's set the upper one near the top. And you see, the nice thing about the Siglent is it seems to do a pretty good job with runt triggering. So I'm a little disappointed with the Rigol, but it may be that I'm doing something wrong. I'll look at that a little more, but that's enough on runt triggers. This is the nth edge trigger function for the Rigol. As far as I can tell, the Siglent does not have this function. I sent them an email a couple of weeks ago asking if there was anything in their repertoire on the Siglent that would allow me to do this kind of triggering, and frankly they never even responded. They didn't acknowledge the email or send anything, and that's in contrast to Rigol. I sent a message to them about the same time on another issue, and they got back to me right away. In fact, Jason, who has done a bunch of videos on their website for YouTube, was very helpful. So that's kind of a downer for Siglent to just ignore their emails. It was sent to the exact address that their website says to send it to, but no response. At any rate, so I'm going to assume that Siglent does not have nth edge trigger. Now let me show you first what nth edge trigger is all about, and kind of an example here. If you this is a simplified diagram of a fairly typical circuit in particularly in embedded systems today. You have 4 signals, A, B, C, and D, that you want to select and apply them one at a time to a latching modulator. The modulator latches on the negative edge of the signal. The counter, which advances the selection, so it starts out at 0, 0, which is A, and then 0, 1, 1, 0, 1, 1, and then goes back to 0, 0 again, triggers on the positive edge. So basically, the signal goes high, the clock advances, the signal is selected and settles on the input, and then at the trailing edge, the descending edge, it's latched into the modulator, and then that, for example, might generate a particular tone, a marker of space, or whatever. The reason that nth edge trigger is useful is, suppose that you want to trigger on, say, the 3rd or the 30th or the 3000th or the 4096th pulse in this train. And there certainly are selectors that select at least 64 levels or 64 signals and even more in some complicated systems. And that's what nth edge trigger allows you to do. So here, for example, is a burst of pulses that occur separated by quite a bit. This is 1 millisecond per division, so that's every 5 milliseconds there is a burst. And now let's zoom in a little bit. That's the burst. Now right now I have it set to trigger on the first edge. And then if you watch as I change the edge number, it jumps to the next one, and the next one, and the next one. That's what nth edge trigger does. It's a very useful trigger, and I can see lots of applications for it. I wish the Siglent had one, but it apparently does not. So this is one of those that's a big plus for Rigol. Let's look now at the delay trigger, another function that the Rigol has that the Siglent does not. However, I think this may be one that you can do with the pattern trigger on the Siglent, but we'll see that later. At any rate, on the Rigol, the way this works is you set up the type. You set, it's a 2-channel measurement. Source A, in this case, is channel 2, and the edge A is falling. This is channel 2 down here. Source B is channel 1, and the edge type is rising. So in other words, it's triggering on a delay between this falling edge and this rising edge. This is channel 1, but it's source B. This is channel 2, source A. Then you set the delay type here, and I have it greater than, and the amount is 1 microsecond. So now what I'm going to do is I'm going to cause the delay between this falling edge and this rising edge to approach 1 microsecond. It's 1 microsecond per division, so that's right on a microsecond. And it says it has to be greater than a microsecond. You may notice that this is moving slightly to the right there, approaching that other edge. And at that point, it loses trigger because now the delay is no longer a microsecond or more. If we go back just one step, it will trigger. So in other words, it's allowing you to trigger on the difference between an edge of one signal and an edge of another. You also can, of course, change, you can select source A can be rising or falling, source B can be rising or falling, so you could do from falling edge to falling edge or from rising edge to rising edge, etc. It's a useful feature, and particularly where you're looking at bus timings and you need to trigger on an anomaly, I think it would be a very useful feature. Once again, it's the delay trigger on the Rigol. Quick add-on, I tried to find any description of the delay trigger on the Rigol website, their YouTube videos, any of that. They have a set of videos, a playlist with the advanced trigger functions, but even though the Rigol has the delay, it does not appear in any of their videos. So what you see here is what I have learned from playing with it, and if I've gotten something wrong, well, perhaps someone can correct me, but at the present time there's no videos on YouTube that talk about the delay trigger on the Rigol, so this is as best as at least as I could get it. Now I'm looking at the setup and hold trigger for the Rigol, and once again this is a trigger mode that the Rigol has that the Siglent does not, although I've said before, because of the pattern mode in the Siglent is so versatile, I think you can do the same things with the pattern mode, although it may not be quite as convenient, but nonetheless it can be done. And one point that I should make about all of these triggers, a lot of them are more about convenience. In other words, there's often more than one way to skin the cat. I guess if you like cats, maybe you prefer to skin dogs, but whatever. When you have a specialized trigger mode or a specialized measurement mode or whatever, that doesn't mean that you have to use only that there isn't some other way to accomplish the same thing. But so that we can talk about what setup and hold might do for you. And basically what the setup and hold does is it measures the amount of time that, for example, a data signal is stable before the clock signal. In this case, assume that the clock signal, that the latch occurs when the clock rises, the rising edge triggered. The setup time is the time before that edge that the data line has to be stable for the latch to work reliably. Similarly, the time after the clock edge that the data line has to remain stable is called the hold time. And once again, the Rigol allows you to set up for either setup time or hold time or both. And up here I have set a signal that you may be able to see. Let's see if I can focus on it. The delay from the time that the top signal is stable until the bottom channel rises is 1.13 microseconds. I don't know if you can read that. Over here, we have the setup time set to less than 1.15. Now, what I'm going to do is decrease that time below the 1.13, and you notice there it's reading 1.12, and the oscilloscope loses trigger. So when we increase it until it just triggers, you'll notice there the setup time is 1.13 microseconds. Now let's go look at hold time. We switch to hold time by pressing this setup type button. You'll notice that it allows you to do setup or hold, or setup and hold. I'm just going to go to hold time, and that's the amount of time that it holds after the clock. And here the hold time is set to less than 1 microsecond. And so we're going to have to increase that. I had to enter the hold time. That was taking too long just to scroll up there. By the way, that's one thing I like about the Rigol. I'll show you in a second how you can set those values. You notice that in this case the hold time says that it has to be, it's checking for less than 3.37 microseconds. And if you look up at the waveform, you see that is the amount of time. It's the time that the signal is stable. Remember, this is 1, 2, 3, and 0.7 microseconds, or 3.87 it actually is there. And when that value is less than that, the scope won't trigger. When you set the value higher than that, in other words, you're within the allowable hold time, then the scope will trigger correctly on that. I mentioned something earlier that I really like about the Rigol. You can, if you press the hold button a second time, or actually the multifunction button a second time, a little keyboard comes up that allows you to enter values rather than having to scroll. I like that feature. I haven't seen it on the Siglent. I'm going to look for it next time that I'm using that scope. So I think this is all for setup and hold for now. I'm going to talk more about it when we talk about the pattern trigger on the Siglent. This is a timeout trigger on the Rigol. The basic function of a timeout trigger is to allow you to set a period, and if the pulse lasts longer than the period you've set, the scope will trigger. The idea being that you set the timeout for the pulse you're expecting, and if there is a pulse that is takes longer than that, then the scope will trigger and show you that situation. So the way I have it set right now, it is set to 5 microseconds, and then I will raise that slightly, and as you see, as it goes just above 5 microseconds, it loses the trigger. So it does not any longer match the timeout period. As long as the timeout is set to an amount that is less than or equal to the, in this case positive, since it's positive slope, to the positive period, then the scope will continue to trigger. And this is the same signal on the Siglent, and here we're using the mode they call dropout, which, when it's set to the state type, and I'll show you the other one in just a second, the dropout on the Siglent is equivalent or identical to the timeout on the Rigol. So if our time, which is here, set to about 4.98 microseconds, as we increase that time to above 5 microseconds, you see that it loses the trigger, just as the Rigol does. So in this mode, it's exactly the same as the Rigol. However, there is a second mode on the Siglent, and it will allow what they call edge, in which case it does exactly the same measurement, but instead of going from a rising to a falling edge, or a falling to a rising edge, in other words, half the period, it does the entire period. So let's look at that one. So I've changed this to the edge type, and you notice the time is just under 10 microseconds, because now it's measuring from the rising to the next rising edge. And as the time goes above 10 microseconds, you lose the trigger. So the Siglent in the dropout mode has two modes, one equivalent to the Rigol's timeout and another which is a second useful mode. So basically the dropout in the Siglent is the Rigol's timeout plus one extra mode. So far we've compared the various triggers of the Rigol and the Siglent. All of these except the video trigger, the ones that are checked over here. The ones that we have left are the duration and pattern trigger, which I'm going to do next, and then the bus trigger and decodes. So I'm hoping to finish up with two more videos. This has run longer than I had expected. The first one is going to be about the duration and pattern trigger in the two scopes, and the second, the bus decode and trigger functions for these three types of buses. So here is a summary of the similar pattern and duration triggers in the Rigol. In both cases, they are the AND of either a high level, a low level, a don't care, in this case a rising or falling, whereas in the duration trigger that's the AND of a high or a low or a don't care and a time, that is a duration. So they're essentially the same, or a way to say it is the duration trigger is exactly the same as the pattern trigger, but with the addition of time and the deletion of rising and falling edges. If you compare that to the pattern trigger in the Siglent, it's the AND or not AND or NAND, not or nor, of high, low, don't care, and time. So in other words, it is the same as the Rigol pattern trigger, only you have additional options of ORing, NANDing, and NORing these signals together. So I'm going to primarily compare the pattern trigger of the Siglent to the duration trigger of the Rigol. So this is a sketch that I've prepared to try to illustrate how you could use a pattern trigger that has timing. In other words, either the duration trigger of the Rigol or the pattern trigger of the Siglent to trigger on setup or hold violations. And what I have shown here is the data line, and the setup time is the time that the data line must be high before the clock goes high. This is the clock line. The hold, of course, is the time that the data must remain stable after the clock transition. So down here I have repeated the D signal, that is a data signal, just an arbitrary wave shape. Here is the D inverted, which is simply the, if you have this on, say, channel 1 of the oscilloscope, and you invert channel 1, this is the signal that you'll see. And then down here is the clock signal, and for example, if this is on channel 2 of the oscilloscope, then this is the D signal ANDed with the C signal, which you can AND in either of the scopes. If you then measure the duration of this pulse, I think you will see lining up. What you are actually doing is you are measuring the hold time of the signal. In other words, the time that the data signal remains after the clock has transitioned. I've set up the Siglent to work with the pattern trigger, and I have it set to look for an AND that lasts less than 2.37 microseconds. So the scope is now set up, And over here on the generator, I have the phase between two square waves, well, I'm sorry, between a square wave and a pulse. And right now it's set at 33 degrees, and I'm going to raise that to 34, but I want to watch the screen as we do, because what we're looking for is a hold time that is less than 2.37 seconds. So when I go to 34, you'll notice the scope triggers. And what is actually going on is that is the first time that the overlap between this signal and this signal, let's assume this is the data signal and this is the clock, the overlap is less than 2.37 microseconds. So now let's go over and do the same thing on the Rigol. I've set up the Rigol to do duration, as I pointed out in the introduction to this video. The duration trigger of the Rigol is very, very similar to the pattern trigger of the Siglent. And what I'm going to do now is I have it set up, and I'm going to try to get, well, I don't think it's going to be able to, you'll be able to see me change this, but I'm going to change the phase of the pulse relative to the square wave. I'm using the square wave as the clock and the pulse as a simulated data. And as I do, you'll see that the Rigol triggers as well. Now, the way the Rigol is set up is the type is duration. You set the source, and in this case you may notice I have channel 1. Apparently you can pick any one of those channels, doesn't matter, because you get a little window down here that shows the basically the pattern, with channel 1 on the left, channel 4 on the right. Now if you use the MSO feature, which I'm not doing in this video, then you get the full 15 or 16 channels of the MSO. But channel 1 is set to high, channel 2 is set to high. That you do with the code button. Then you set when, and in this case I have when less than, and then you set the time, and I have it set to the same value I had on the Siglent, 2.37 microseconds. So let's lower the generator, restart the oscilloscope, and once again we're looking for a hold violation that is less than 2.37 microseconds. And as soon as I turn it to that, the Rigol triggers. So these two scopes perform almost identically. I hope you've enjoyed this re-edited video on the trigger functions of the Siglent and Rigol oscilloscopes. And if you did, then I hope you'll stay tuned for the next one in this series, which is going to be a re-edit of the decode functions and some additional parts that originally were separated into smaller segments. Once again, thanks for watching. Look forward to seeing you in the next video.